we had seen an important update, that is rectilinear propagation of light. So all of you keep your cameras on. So what do you mean by rectilinear propagation of light?
Propagation of light in a straight manner.
Yeah. So the propagation of light in a straight path, or light always travel in a straight line, that we call as the rectilinear propagation of light. Now here we will be talking of refraction of light. So refraction of light means bending of light as light moves from one medium to another medium. So one medium and another medium, we say that the two mediums should have the different optical densities. So refraction is bending of light when it travel from from one medium to another. So basically the light changes its path when the light travels from one medium to another. Light changes its path, and this phenomena we call as the refraction of light. So here we observe, in the refraction of light, we observe certain phenomena related to the, we observe certain phenomena due to the refraction of light, like the bending of we observe the bending of a pencil. So I will show you one of the phenomena here, the bending of pencil. Let's see. Uh, we can see some phenomena here, bending of pencil. So bending of pencil in water. Let's see. This is how we observe. If you keep, you can see here, if you keep a glass of water, and in that glass, if you put a pencil, so you will observe the pencil being bent something like this, or even not completely like this. So at least something like this you will observe. Okay, you will observe that your pencil has been bent like this. So this phenomena we observe because of the refraction of light. There are certain other phenomena which occur because of the refraction of light only. Okay, as we go through the chapter, we'll see more phenomena that occur due to the refraction of light. Like due to the refraction of light, we observe the lateral displacement. Due to refraction of light, we observe different positions of the objects. Your working of the lens is also an important phenomena which is based on the refraction of light. Okay, so see how we actually see here the refraction of light. We consider two medium, as we know that light travels fastest in vacuum, and we know the speed of light in vacuum is 3 times 10 to the power 8. So the speed of light in vacuum or free space is 3 times of 10 to the power minus 8. That's the speed of light in vacuum, 3 times 10 to the power 8 meter per second. The same speed of light in other medium, if you find the speed of light in some other medium, that's less than this. So this is the fastest speed. If you say the speed of light in water, the speed of light in glass, the speed of light in diamond, so that will be less than the speed of light in different other substances. It will be different. Now the speed of light in vacuum will just be 3 times 10 to the power 8 meter per second. So here we consider two medium. Let's say you have here air, like, and here we have water. So just like we observed in the case of glass, we observed in the case of glass filled with water. So we consider here a ray of light coming towards, let's say you have a ray of light which is coming, and it's incident obliquely on the interface between air and water. So the ray of light is incident obliquely at the interface between air and water, and at this point, at the point of incidence, I can draw the normal. As we know that the normal is perpendicular to the surface at the point of incidence. So here you can observe this is your incident ray, and this one we have normal at the point of incidence. Okay. The ray was expected to travel along its path. The ray was expected to travel along its path like this. But actually, the ray of light does not travel in the same path as it is expected. We observe some bend in the path of light. This is the expected path that we observe for this ray of light. So the ray of light here does not travel like this. The ray of light, it bends its path or it curves its path. So the ray of light, it bends something like this. It bends towards the normal, like this. So this phenomena of the bending of light when it passes from one medium to another, we call as refraction of light. Okay. So why this phenomena occur? Why the refraction occur? As we have studied about the reflection. So here a proper reason for the refraction of light is that the speed of light changes. When light enters from one medium to another medium, the speed of light changes and hence you have the refraction of light. Hence there will be the refraction of light. Okay. So here let me have this angle of incidence and this one as the angle of refraction. Since I observe that the speed of light in air is c, I denote this with c. C will always represent the speed of light in vacuum. So the speed of light in vacuum is 3 times 10 to the power 8 meter per second. As this light enters through water, the speed of light decreases. And let us say the speed of light has some value VW. I denote the speed of light in water with the symbol VW. So I can observe refraction occurring. That there is a refraction, there is a bending of light occurring towards the normal. Here we observe that the ray of light bends towards the normal. Okay. Now, what do we expect? Suppose if the ray of light would travel from water to air. Okay. So if I make the ray of light travel from water to air, let us suppose I put here a mirror in front of this. Suppose I put a mirror here. Perpendicular to this, I put a plane mirror. Now the ray of light which was incident, it will get reflected back from water only. So from water, the ray of light will get reflected back. Okay. Here it will get reflected back and it will move away from the normal. It will go the way it has come, which we call as the principle of reversibility of light. So the principle of reversibility of light means the ray of light, it traverses or it retraces its path if a plane mirror is placed perpendicular to the ray of light. So if you place a plane mirror perpendicular to the a plane mirror is placed perpendicular to the path of the ray of light, it will retrace its path and hence we can observe that now the ray of light will travel away from the normal. See, if the ray of light travels like this, so it will go like this and it will, as I can observe, it is bending away from the normal. I can observe a bend away from the normal. So we can keep here a point of view that when ray of light enters from a rarer medium to a denser medium. So what medium we can call as the rarer medium and what medium can we call as the denser medium? Okay. So which medium will be called as a rarer medium? What medium we will call as a rarer medium? See?
The one with incident.
No. The medium in which the speed of light is small. Speed of light is high. That we'll call as the rarer medium. So medium in which light travels fastest. In which light travel faster.
So in this case, the incident rate.
Yeah, in this case, obviously air is the rarer medium. Okay. So medium in which light travel faster will be rarer medium. Rarer means the particles are quite away from each other. Okay. So we generally don't call that particles away from each other because we have a term called as optical density and mass density. So here we are not mainly talking of the mass density, we are talking of the optical densities. So optical density, in terms of this, I define a denser medium. A denser medium will be the one in which the speed of light is small. We will call this medium in which speed of light is small or less. So medium in which the speed of light is less is we call as the denser medium. So if we here we observe, we'll call this air to be a rarer medium. We'll call this air as rarer medium and this water as denser medium. So we have these two, a rarer medium and a denser medium. Is everyone clear about refraction of light?
Yes.
Yes, sir.
Okay. So a point is to be noted that if ray of light travels from a rarer medium to a denser medium, so it bends. If the ray of light travels uh, from a rarer medium to the denser medium, it bends towards the normal. This is an important point here. So, if a ray of light travel from rarer medium to a denser medium, if a ray of light travel from a rarer medium to a denser medium, then it bends towards the normal. Normal. And if it travel from from denser medium to a rarer medium, so if it travel from a denser medium to a rarer medium, it bends away from normal. So in this way, we can make some of the conclusions here. We can draw some of the diagrams. Let's see. Again, so here I have taken a few media. Let's say we make these three media here. So you have this medium one, let the medium one be air only. And from air, you have a ray of light that is incident at the same angle of incidence. So the ray of light is incident at the same angle of incidence and on all the three refractive surfaces. So on all these surfaces, you have a ray of light which is incident at the same angle of incidence. You have the same angle of incidence I everywhere. Now, if I observe the refracted ray of light, so this is your incident ray, and now I can draw the refracted ray. So here I draw the refracted ray bending like this. Here I observe the ray of light bending like this. Here I observe the ray of light bending something like this. And here I observe the ray of light bending still more. So out of media, let this be medium 1. And here we have made this medium 2, medium 3, and medium 4. Okay. So out of this medium 1 and 2, which one is the denser medium? Yes, out of 1 and 2, which one will be the denser medium? 1 or 2?
2.
Yeah, 2 is the denser medium. And out of 1 and 3?
1.
1. And out of 1 and 4?
4.
4.
4. And can you say anything about 3 and 4.
Sir, 4 is denser.
3
Sir,
and 4.
4 is denser than 2.
Yeah, 4 is denser. So can you compare all of them? Out of them, which one is the most denser? Most dense?
4.
4.
4.
4. And which one is the least dense?
3.
3.
3. Okay. So that means everyone has understood how to draw these diagrams. Now let us define a numerical aspect to this. A numerical aspect to this here we will be dealing. We will define a criteria to find out that which one is a denser one and which one is a rarer one. Okay. To find out which one is the denser one and which one is the rarer one, we define an index which we call as the refractive index. So here we define refractive index of the given pair of media. So refractive index for the given pair of media, it is the ratio of speed of light in air to the speed of light in that media. In that medium. So this we also call as something, a word we call as the absolute refractive index. When we are fixing our medium 1, if we fix the medium 1 to be air, so we call this refractive index as the absolute refractive index. So this is our absolute refractive index. Whenever we talk of absolute refractive index, so you should see that yes, the first medium, it means that the first medium is air. If you think the medium is air. Okay. So how we write this? The symbol refractive index, different books use different symbols. So there are two most common symbols which are used for writing down the refractive index. So we write refractive index either with symbol N. So N is equal to C by V. Okay, C by V, where C is the speed of light in air, which is fixed. Speed of light in air is 3 times 10 to the power 8 meter per second. And V is the speed of light in the given medium. Okay. So this value we call as the refractive index of that medium. For example, we know certain refractive indices. So let's say here, let us have here a list of the refractive index. Yeah, sure. Every year, some question is to be based on this refractive index. So we'll try to do a few questions based on this refractive index.
Sir, you can.
Okay. So here. So I'll give you the refractive index of certain materials, and then we'll try to find out some questions, do some questions based on this refractive index. The refractive index of common materials, some common materials we want to see. Okay. So here, there are different lists. You can check up any of them, as this list gives you the refractive index of certain materials. See, the refractive index of vacuum is 1, which means light travels fastest in vacuum. If you divide, and its speed in air or vacuum is 1, that means 3 times 10 to the power 8. The refractive index of air is very close to 1, 1.000277. It's very close to 1. So for all practical or your calculation purposes or all practical purposes in this chapter, we will take them to be the same. We will take the refractive index of vacuum or refractive index of air to be the same. Okay. Now the refractive index of water is given as 1.33333, and if you convert it to fraction, it would be 4 by 3. So don't forget, if you are given somewhere 1.3333, Remember, it's equal to 4 by 3. Okay. So this
Yes, sir.
1.333 is 4 by 3. Refractive index of ice. See, water and ice, they have different refractive indices. The refractive index of ice is 1.31, which is less than water. The refractive index of glass is nearly 1.5. So you can write it as 3 by 2. 1.5 is equal to 3 by 2. So refractive index of glass is nearly 1.5. Refractive index of diamond is 2.47, which is highest. Diamond has the highest refractive index. It's 2.417. Okay. Now, what does it mean? What do these values mean to us? Can you tell
Sir,
out of these? Yes,
sir, it will be denser, sir, more.
it will be denser. So, suppose if I want to compare these two, I want to compare water and glass. Okay. As you can see, water has a refractive index given by 1.33. Glass has a refractive index of about 1.5. So, which one will have a higher speed of light? In which of them will light travel the fastest? Out of water and glass, where should the speed of light be maximum?
Water.
Water.
Water. Okay. So the speed of light in water will be faster than glass. Okay. So your refractive index, it tells you that the speed of light in that medium would be 1 over this times of the speed of light in here. You can get it like this. If we put here refractive index, suppose I want to find out refractive index of water. So I put refractive index of water equal to C over V, where C represents the speed of light in vacuum and V represents the speed of light in water. So I can write it as C over V. Now, if I get V, so V will be equal to C by W, C by refractive index. So what your refractive index indicates? Your refractive index indicates that the speed of light in that medium would be 1 over times 1 over refractive index of the speed of light in air. This indicates the speed of light in that. So let's do one question here. Try to do this one question. The refractive
Sir,
index of
C
water,
is, sir, what
yes,
C again?
C is speed of light in vacuum, which
And we
is 3 times 10 to the power 8. Okay. Find the speed of light.
sir, what is V?
Yes,
What is V?
V is the speed of light in medium. Like if you are talking for water, so this V is the speed of light in water. So you have to find the speed of light in water. Given that speed refractive index of water is 4 by 3. Okay. So can you solve it out? Solve it out now. Okay. So we will use the formula of refractive index here. The formula of refractive index says that refractive index in water should be equal to C by V. We are supposed to find here V. So V will be equal to C by refractive index. So the value of C is 3 times 10 to the power 8 divided by refractive index. Now the refractive index of water is given as 4 by 3. So we put here 4 divide by 3. So this 3 goes to the numerator. You get here 9 by 4 multiply 10 to the power 8. Simplify it, you get 2.25 meter per second. 2.25 multiplied 10 to the power 8 meter per second. Okay. So in the similar way, can you find out the speed of light in diamond? Can you find out the speed of light in diamond?
Yes, sir.
Okay, so find it out. Let us take the refractive index to be 2.42. We are given the refractive index as 2.42. Do you have any other class after this?
Sir,
Math.
maths.
Maths class. At what time?
7:10.
7:10. Okay, so we can continue for another 3 minutes. Okay, find out the speed of light in, let's say I'm giving you these two questions. The refractive index of glass is 3/2. So find the speed of light. Find the speed of light in glass. Okay, so how many of you have done this question? I think you could have done. Find the speed of light in glass.
That
Anyone got the
is it
answer?
2 into 10 to the power of 8 meters per second.
Yeah, it's 2 into 10 to the power 8 meter per second, right? So you get here the speed of light in glass. I can write speed of light in glass as 2 into 10 to the power 8 meter per second. So depending on this, today we learned about the absolute refractive index. So depending on this, you also have some relative refractive index. We will study about relative refractive index in our next class. Okay. So bye everyone. Good night and take care.
Bye, sir.
Bye, sir.